Hello friends, how are you? I hope you all are good. Now in our topic carbon and its compound, we are discussing about derivatives of hydrocarbons. Okay, so see in derivatives of hydrocarbon. Okay, so see here we have to write first here definition derivatives of hydrocarbon. So see here if hydrogen, okay, if hydrogen of of a hydrocarbon is is displaced by it displaces from other atoms, it displaces from other atoms or group of atoms, other atoms or group of group of atoms. Such compounds are known as such compounds are known such compounds are known as derivatives of hydrocarbon. Such compounds are known as derivatives of derivatives of hydrocarbons. Okay, if hydrogen of hydrocarbon is displaced from other atoms or group of atoms, okay, it's called as what? Derivatives of hydrocarbons. Okay, for example, see here, for example, so many are there. For example, here alcohol, okay, then ether, then aldehyde. Okay, so these are what examples. Now how we can characterize, okay, so see here we can characterize in small a and small b point, so concentrate on this with example. Now we will discuss here hydrocarbon group, or we can say what? Radical. Small a what beta here? Hydrocarbon group, or we can say what? Radical. Okay, so hydrocarbon group. So see here, when one hydrogen is removed from hydrogen, when it will hydrocarbon group or radical, it will produce. When one hydrogen is removed, when one hydrogen is removed from what beta? Hydrocarbon. Okay, so see here, for example, when one hydrogen is removed from hydrocarbon. Okay, so see here how we can see here example. Suppose this is what your hydrocarbon, CH4 is what your hydrocarbon. Okay, so suppose one of the hydrogen is removed. So what we can call it as a bond CH3. One of the hydrogen is replaced or removed. So what we call it this group? What? Methyl. Okay. So like that, in C2H6. So C2H6 is what? Ethane. So here one of the hydrogen is replaced. So what? Bond C2H5 means one of the hydrogen replaced. So here we want to maintain what we want. We have to maintain here carbon valency, or this you may write like this. Okay, C2H5. Understood or not? So see here like that we have to write. Understood? C2H5 means bond CH2 CH3, or we can write what? C2H5. Okay, so these are what here? Hydrocarbon group, or we can say radical. So whatever this, so see here, okay, whatever this bond CH and bond C2H5, we call it as a what? We are designated as, so see, whatever these we are getting, we are designated as what? R. Okay, capital R. It is denoted in your organic compounds, capital R. Okay, so these are what beta here? Yes, these are what? Hydrocarbon group, or we can say radical. Okay, so like that here isopropyl, then propyl, butyl group also we can form. So that we can designate it as a what? Capital R. So see here, one of the important here you must know saturated and unsaturated. Okay, so in saturated and unsaturated, I already discussed singly bonded means what? Yes, it is singly bond. Okay, singly bond means what? Yes, we call it as a what? Saturated. Saturated. Okay, doubly bond we call it as a what? Yes, double bond. And what beta here? Triple bond. Okay, triple bond. So we call it as a what? Unsaturated. Unsaturated compounds. Okay, so these were simple alkane. Yes, these are what? Alkenes. ENE means double bond, ANE means single bond. Here what is alkynes? YNE means what? Triple bond. Singly bonded means saturated, and whatever doubly and triply bonded, these are what? Yes, unsaturated. Okay, so now we will discuss theory about whatever functional group. Okay, so we are going to discuss what? Functional groups now. So see here, in functional group, what we have to say. First, we will discuss the definition of functional group. Okay, so ready with this functional group definition. So see, we have to write here point functional group. So see here, functional group. So what is a functional group? Okay, so as you discuss, or you may know functional group as a what? Acid, aldehyde, esters. Okay, these are what? Then your alcohol is what? Functional group. So see, we will write here definition. An atom or a group of atoms. So see definition, proper definition. An atom or group of atoms. An atom or a group of atoms which displace the hydrogen, which displace, yes, which displace hydrogen. Okay, which displace hydrogen atom from, which displace hydrogen atom from hydrocarbon. From what beta? Yes, from hydrocarbon. From hydrocarbon molecule. From hydrocarbon molecule. It's called as what beta? Functional group. It's called as what? Functional group. Okay, so these are our definition of functional group. An atom or group of atoms will displace hydrogen atom from hydrocarbon molecule is called as functional group. So it determines, so basically whatever your functional group, it determines what? It determines the chemical characteristics or chemical properties of an organic compound. Okay, whatever your functional group, it determines what? Characteristics, chemical characteristic, or we can say properties of an organic compound. Okay, so now we will categorize this. Okay, formula of functional group. Now pay attention here, how we can categorize this. See here, formula of functional group. So we will write here. Okay, formula of functional group. Okay, then here what? Name of functional group. Yes, name of functional group. Okay, then a type of organic compound. What beta? Type of organic compound. And what? Family. And what? Here, family. Okay, so see here, formula, then name, then type. Okay, and what? Family. So see here, first we will discuss whatever. Okay, see, first we will discuss here halogens. What beta? Halogens we will discuss first. Now see here, these all chloro, okay, then bromo, then iodo, and is what? Fluoro. Yes or no? Chloro, bromo, iodo, fluoro. So we can write here, beta. Yes, chloro. Name is what? Chloro, bromo. Yes, iodo. Then what? Fluoro. Okay, understood. So type of organic compound. How we can write? Yes, RCl. R means what? Whatever your hydrocarbon, when it is replaced by one of the what? Hydrogen. CH3Cl, C2H5Cl, like that. RCl, RBr, RI, then what? RF. Okay, understood. So these are, we can say, what? Halogen family. Which family? These are halogen family. Okay, so now see here, these are what? First we can say. Second, bond OH. So here name of functional group is what? Yes, what we call it as a hydroxy. Name of functional group we call it as a what? Hydroxy. Type of organic compound is what? Yes, ROH. And family is what? Yes, alcohol. Family is what, beta? Alcohol. Then here, third. So pay attention on the third also. Bond C double bond OH. These are what? Yes, aldehyde. Okay, aldehyde. Here what? We can write R C double bond OH. Then family also what, beta? Yes, aldehyde only. Okay. Now see fourth one. Fourth, like this linkage. Okay. These are what, beta? Bond. Two bonds here and C double bond O. Yes. What we call it as a ketone. What we call, beta, here? Ketone. Okay. And type of organic compound like this we have to write. C double bond O, and here also R. Family also what, beta? Yes. Family is also what? Ketone. Okay, so this here fifth. So see here fifth. Like this bond C double bond OH. Okay, we call it as a what here? Carboxy. What? Carboxy. And whenever you have to write type of organic compound like this, you can write like this also, or C double bond OH. Okay. Here what? Yes, acid. Okay. Now see here, alkoxy also there. Okay. Then here we have to write, say, ester. We can write bond C double bond O R. Here what, beta? Yes, esters. Esters. We can write this as a RCOOR, and what here? Esters. Okay. So these are what? Formula, name of functional group, type of organic compound, and what, beta? Family. Okay. So these are what? Few importance. Okay. Some are there. Ether also there. ROR. Okay. Yes, what, beta? ROR there. ROR is what? Yes, ether. Okay, then amine also there. RNH2 is what? Amines. Okay, so these are another functional group also present. Some are for higher standard, some are for your 10th standard. Okay, so see here, these are very much important. You have to keep in mind this. Suppose aldehyde, so which formula, type of organic compound, functional group formula, so you must know here. Ketone means what? Okay, like this. So this chart is very much important. You have to keep in mind, you have to write so many times for your practice. Okay, so keep in mind this. You can add in that ether and amine also, no issues. Okay. So very much important this thing for organic chemistry. Okay, so see here, now we will discuss one of the important part. Okay, that is homologous series. What beta? Yes, homologous series. So see here, in homologous series and its characteristic. Okay, so see here, homologous series. Yes, homologous series and its what beta? Characteristics. So these are, it name itself indicates what? Homologous. Homo means what? Similar. So it contains some similar, they having chemical property, physical properties, or we can say what they having a similar general formula. So beta, you have to write first definition. So we will write here a proper definition of homologous series. So you have to here, you also must write in your notebook. Okay, whatever I am saying, okay, whatever I am writing on this board. Okay, so see here it can be defined as, see, it can be defined as, okay, a group of organic compounds in which a group of organic compounds in which, okay, group of organic compound in which various members have, in which various members, okay, various members have same what? Same general formula. Before only I told something, it is same. Okay, same general formula with same functional group, with same what? Yes, same functional group. Okay, same functional group. Therefore, similar chemical property. Yes, therefore, what beta? Similar chemical, yes, properties. Okay. So see how much similar. Homo means similar. Homologous series. They have same general formula, then same what functional group. Therefore, similar. Obviously, it will come what? Similar chemical properties. Okay. So this successive member of homologous series, this successive, this successive, okay, successive member of homologous series, yes, homologous series differ in their, differ in their molecular weight, differ in their molecular weight. How much that molecular weight differ? Okay, so much interesting here. Okay, these successive members of homologous series differ in their molecular weight. How much? By one bond CH2 bond group. Bond CH2 bond group. Okay, so these are what called as your homologous series. Now we will see here beta examples, so many examples are there. Okay, so see here example we can write, suppose I will write here CH4. Okay, it is one of the your alkane. So further I will write, okay, further I will write like this CH3. Okay, CH3 and CH3. But how much in this carbon and hydrogen I added? Yes, CH2. Are you understood or not? Okay, means one carbon atom I added and two hydrogen atoms I added. So it becomes beta this what? CH3, CH3. So this CH3, CH3 we call it as the what? ethane. Understood or not? So see this, compare this first. CH2 differ by one CH2. So I added one carbon atom C2 and these two hydrogens. So 6. Okay. Ethane you will get means homologous series. It will differ by atomic mass. How much that differ? 14. Okay, 14 gram. Okay, and molecular weight, suppose molecular weight is what? 14 unified mass, it will differ. Okay, suppose I will write like this. Okay, for example, here, suppose I will write alkene part. Okay, so see, as you know, alkene part, yes, C2H4. Okay, so I have to add. So here what? C3H6 means these what beta? Ethene. Yes or no? So these are what beta? Yes. Propene. Understood or not? Means addition of how much? Addition of CH2 only. One carbon atom and two hydrogen. Okay, therefore having what? Homologous series. So in each we can add such type of CH2 in each functional group. So it becomes what? They have similar chemical properties, they having same general formula, okay, and they differ by only one CH2. Okay, so now we will discuss here characteristics of homologous series. What beta here? Characteristics of homologous series. Okay, so first characteristic we will discuss. First characteristics of homologous series. So see here, first characteristic what they want. Successive members of homologous series differ by successive members of homologous series. Yes, differ by how much? Differ by CH2 group. Yes or no? Having molecular mass, having molecular weight, having molecular weight how much? 14U. Okay, these are what first characteristic of our homologous series. Okay, now see, all members possesses same functional group. All members possesses same what beta? Same functional group. Same functional group. Yes, it is correct. And have a similar method of preparation. And have, yes, and have similar method of preparation. Yes, because it is differ by only one CH2. Other functional group and everything is what? Same only. Okay. Therefore, they have same chemical properties. Yes. Therefore, they have same what? Chemical properties. Understood? Now, third, see here. Whatever the existence of homologous series of organic compounds has simplified the study of organic chemistry. Okay, so with the help of this homologous series, we can study huge number of organic compounds and what millions of organic compounds and their properties. So because of this homologous series, we can what? We can easy to memorize and easy to identify the properties of that organic compounds. Okay. So these are what importance about what your homologous series. Okay. Now we will discuss here whatever nomenclature of organic compound. What beta? Nomenclature of organic compounds. So much important part. Nomenclature of organic compound. Now only we saw what functional groups in that all halogens, alcohols, ethers, amines. Okay, then your aldehyde, ketones, acids, esters. So how we can name this? All that organic compounds. Okay, so that beta we will discuss in our next lecture. So thank you. If you have any doubts, you can feel free to ask anytime. Thank you very much.